Greetings, everybody. In this video, we are going to talk about unit conversions. Now, this is also called dimensional analysis or unit analysis, and it also can be called the factor label method. It's a technique that we're going to employ in doing this. I believe that comes from chemistry. I'm not sure. But anyway, we're going to be dealing with problems like this. Your friend may say, hey, I just bought, 10 kilograms of oranges from the store. And you might wonder, well, what is that in pounds? Right? So how do we convert from kilograms to pounds? Or somebody may say that, hey, I live 5 miles away. But if you're talking to someone from anywhere other than the US, pretty much, they're going to want to know how far is that in kilometers, right? So you need to be able to convert. Okay, so these are the kinds of problems we're going to be looking at. So let's go ahead and take a look. Okay, so here are just some unit conversions that we're going to be looking at here. Now, there are lots of different unit conversions that you can refer to between different quantities. These are just some of them, but these are the ones that we'll be using in our problems. So we have unit conversions for length. Notice that 1 foot is the same as 12 inches. 1 mile is the same as 5,280 feet. And et cetera, et cetera. We have all these different conversions for length. We also have weight and mass. 1 pound is the same as 16 ounces. 1,000 milligrams is the same as 1 gram. A kilogram is the same as 2.2 pounds. That is on Earth, because pounds is a measure of force due to gravity, and kilograms is a measurement of mass. So kilogram does not depend on gravity, pounds does. So depending on what planet you're on, the weight of something can change, but its mass will always stay the same. But anyway, that's for another class. Capacity. We have, you can convert cups to ounces, quarts to pints, pints to cups, milliliters to liters, etc. Okay, so we'll be using these to answer some questions. And the first question we have is right here. How much does 6 kilograms weigh in pounds? Well, let's see. How are they related? Well, 1 kilogram is 2.2 pounds. So what this tells us is it's actually giving us a rate. All right, we can write this as a ratio of these two quantities. Now, because they're equal, that ratio will be equal to 1. So anything we multiply it by won't change its value, right? Because if you multiply something times 1, you get the same thing. Now, what we want to do is we want to convert from kilograms to pounds. So we want the kilograms to cancel. So we want the kilograms to be in the denominator. All right, so I'm going to write this as a fraction with kilograms in the denominator. So I'm going to write it as 2.2 pounds divided by 1 kilogram. Now, like I said, this is equal to 1 because these things are equal. So anything I multiply it by, I will preserve its value, right? So when I multiply this times 6 kilograms, I'm not changing the weight. All I'm going to end up doing is writing it in terms of new units, but the actual amount of weight will stay the same. So this will give me an equivalent measure of weight when I finish this computation. Well, let's do the computation. Kilograms are in the numerator here, and then they're in the denominator here, so they cancel. They are factors of the numerator and denominator, so they cancel. And what's left over? Well, I got 2.2 times 6, which is equal to 13.2. And if we look at the units that are left over after I've canceled the kilograms, I'm left with pounds. And so we have successfully converted kilograms to pounds. Notice how the units match what we need. And so that's a great check to make sure that we did things all right. All right, the next problem. And hello there. I like to pop in every once in a while so you know there's an actual human behind the screen. So in this problem, how much does 10 pounds weigh in kilograms? Okay, well now we want to convert from pounds to kilograms. So we want the same ratio that we had before, but with pounds in the denominator, so I cancel the pounds. So I'm going to take that same ratio we had before. 1 kilogram is the same as 2.2 pounds. And I'm going to multiply this by 10 pounds, knowing that because this is equal to 1, these are the same, right? I'm not actually changing the value, I'm just expressing it in terms of new units. And what do we get? The pounds cancel, right? They're factors of the numerator and denominator. I get 1 times 10 divided by 2.2. And this is measured in kilograms. And 10 divided by 2.2 is 4.545 dot, dot, dot. All right. So I'm going to round that to 4.55 kilograms. And that is our final answer. All right, next up we have some more problems here. These are going to be a little bit more involved. It says how many ounces are in a kilogram of water? Okay, so if we look over here at our units, we need to convert from ounces to kilograms. Now you'll notice that no one of these equalities actually do the job. There's no one of these equalities that actually goes from ounces to kilograms. So we actually have to link several of these together. Okay, well, if I look at the first one, I can get from ounces to pounds. And this doesn't have anything to do with it, but then, oh, here we go, pounds to kilograms. So I'm going to link these two together, ounces to pounds, pounds to kilograms. So I'm not going to multiply by just one thing, I'm going to multiply by two things to get to the answer. Okay, so what we're starting with is a single kilogram. It says a kilogram. So we're starting with 1 kilogram. And I'm going to multiply this by 1, right? We're always multiplying by 1. And we want to go to pounds, right? So I want pounds to be in the numerator. So I'm going to multiply by 2.2 over 1, 2.2 pounds over 1 kilogram. Okay, and now we're going to want to go from pounds to ounces. Right, so we want to end up with ounces in the answer. So I'm going to put this in the numerator and pounds in the denominator. So 16 divided by 1. That's 16 ounces for 1 pound. Now let's just check to make sure that the units work out. Notice that the kilograms are going to cancel here, and the pounds are going to cancel here. And this is exactly what we need. We need to be left with ounces. And so let's multiply all this stuff together and see what we get. Well, in the numerator, I have 1 times 2.2 times 16, 35.2. And I'm left with ounces in the numerator. Now, what are we left with in the denominator? Well, 1 times 1. So I'm dividing by 1. It doesn't do anything. So this is my final answer, 35.2 ounces. Okay, in this next one, we are being asked how many kilograms are in 15 ounces of water. So it's like the other one, kilograms to ounces, but the other way around. Here we're converting from ounces to kilograms, but we're going to use the same conversions, but we have to do it in the other order. All right, so we're starting with ounces. So I'm going to first use this relationship. Now I want to cancel the ounces, so I'm going to multiply 15 ounces times 1 pound over 16 ounces. That will cancel the ounces. So now we have pounds. All right, so now we need to get to kilograms from pounds. So I go to this other relationship here. 1 kilogram equals 2.2 pounds. I want to cancel the pounds, so I'm going to put the pounds in the denominator. So what I'm going to write is 1 kilogram divided by 2.2 pounds. And that cancels the pounds. So what we're going to do now is compute this out. In the numerator, I have 15 times 1 times 1. So in the numerator, I have 15. In the denominator, I have 16 times 2.2. That's 35.2. And what are the units? Well, everything canceled except the kilograms. So that's just kilograms. So now we just have one final computation remaining, and that is to simplify this. Right? Well, 15 divided by 35.2 is 0.426. So I'm going to round that to 0.43. And this is measured in kilograms. Because it was 2.6, I round the 2 up to 3 because the 6 is greater than or equal to 5. And this is our final answer. 15 ounces of water weighs 0.43 kilograms. how many meters are there in 3 miles? Okay, so we need to convert from miles to meters. Let's see if we can figure out a way to do this. All right, well, we're looking at lengths, right? Is there any direct comparison between miles and meters here? Well, unfortunately not. The only thing that has miles in it is this. So I can go from miles to feet. Okay, so now I'm in feet. Now, where can I go from feet? Well, I can go to yards, but I don't see anything else with yards in it. Oh, I can go from feet to inches, and then inches to centimeters, and then centimeters to meters. All right, so that's our path here. Okay, so let's go ahead and do that. So we're starting with 3 miles. I'm going to multiply that by, what did we say? We said, 5,280 feet per mile. And I'm going to make it so the miles are in the denominator to cancel the miles. Now I'm going to be left with, see, these miles are going to cancel here. I'm left with feet. So I want to convert the feet to something. And we said we could do feet to inches here. And I want the feet to cancel, so I'm going to put the feet in the denominator. Okay. Now we have canceled the feet. We want to deal with the inches. Well, we got to turn inches into something. We're going to convert the inches into centimeters. So we know there are 2.54 centimeters per inch. So I want the inches to cancel, so I'll put that in the denominator. Okay, and I'm going to have to get out of the way here because we need to do a little bit more, right? Now we need to convert centimeters to meters, right? So I want to, notice I canceled the inches here. I want to cancel the centimeters out now. So I want the centimeters to be in the denominator. So I'm going to write this as 1 meter divided by 100 centimeters. And that will cancel the centimeters. And so you can see in this chain, we have canceled everything and except for the meters are left. And that is what we want. So this is the computation we have to do. We need to compute 3 times 5280 times 12 times 5.4 for the numerator. And that gives us exactly this. And we need to compute 1 times 1 times 1 times 100 for the denominator. Well, that's easy. That's just 100. And what are the final units here? Meters. So that, and this is exact. I didn't round. So this is exactly equal to this. When I divide by 100, what happens? This decimal place just moves over 2 spaces. So I think we got our answer. So let's see. It's 4,228. Oh, 4,828.03. I'm going to round to 2 decimal places here. So because that number is less than 5, I'll just round to 0.03. And these are meters. And that's approximate because I did round. So 4,828.03 meters.